All right, an infinite series has the nth partial sum. What is the sum of the series? So we're just going to do limit as n goes to infinity of that, and that will give us our answer. You're just taking this out forever and ever and ever. So what would that limit come out to? 3/5. Now I kind of have this separated for you. It says determine whether the geometric series converges or diverges, and if it converges, you're going to find the sum. Your little formula is up there. All right, so for this one, A is 4. R is, let's see, what are we multiplying by each time? -1/3. So converges or diverges is your first question. Converges. So we would say converges because absolute value of R is 1/3, which is smaller than 1. I'm not going to make you say that it's geometric because I told you it was geometric in the problem. But let's say they were all mixed up. I would want you to say it's geometric. Do you get what I'm saying there? Like if it's all mixed up and you're not told, you need to mention this is geometric. All right. Oh, good.
For 1. Wait.
All right, so we are going to actually get the answer, and how would we set that up? Good. It would be usually 1 minus, but it would be minus -1/3, so plus 1/3. So that is 4 over 4/3, which would be 4 times 3/4, and the 4s cancel. So your answers. You can add up numbers forever and get 3. It's cool. All right, what do you think about B? Converges or diverges?
Diverges.
Diverges. So we would say diverges because absolute value of R is 7/3, and that's bigger than 1. And then you don't have to do the problem because it's not going to work. Yeah, like it's just done. We don't have to actually get an answer. For C and D, it doesn't look geometric at first. So you want to generate the first few numbers in the pattern. I think if you do at least 3, that's good enough. So if you plug in 1 for this one, you would get 9/4. If you plug in 2, you would have 27/16. If you plug in 3, you would have 81/64, and then that's good enough. I can't go beyond that in my head anyway. I would need a calculator. So what is A? A is 9/4. R is, do the numerators and the denominators separately. 3/4. So converges or diverges? Converges. So we would say converges because absolute value of R is 3/4. Just smaller than. And so you have to actually get an answer. When? I know. So when you set it up, it'll be 9/4 over 1 minus 3/4. So that's 9/4 over 1/4. What happens to the 4s? So it's 9 over 1, which is just 9. So again, this one doesn't look geometric to start out with. So let's just generate the first like 3 numbers in the pattern. So if you plug in 1, you would get -1 over e to the 3rd. If you plug in 2, you would get +1 over e to the 4th. And then if you plug in 3, you would get -1 over e to the 5th. So A is that first one, -1 over e to the 3rd. R is what? You want to do the numerators and denominators separately. Yep, -1 over e. E is about 2.7. So is it going to converge or diverge? But yeah, this would be about -1/3, like if you rounded 2.7 up to 3. So that is going to be smaller than 1. So it converges because absolute value of R is 1 over e, which is smaller than 1. This is where the algebra gets tricky because there's an E in there. All right, so your sum is going to be A over 1 minus R. That would be 1 plus 1 over E. I feel like I put one like this on the first quiz. What can we replace the 1 with? E over E, so that you have a common denominator. So I'm going to leave the numerator the same. I'm going to write it with a horizontal fraction bar, though, because I feel like that'll look a little bit better. Takes up more room on the paper, though. And then down here, when you combine them together, you would have E plus 1 over E. And then we were doing this a bunch with our limit comparison today. You would leave the numerator alone and then flip the denominator. So you multiply by the reciprocal. And not a whole lot can be done with that, but you have e to the 1 here, and then you have e to the 3rd. So one of the e's will cancel, and that'll make that be what? E squared, and then e plus 1 is kind of just there. You just got to throw some parentheses around it. That's a great answer. I keep doing that to you. You're probably like, why does she keep doing this to us? Because I saw one from College Board that was like that. All right, so that was geometric. Apply the nth term test. They have k in them, so it's going to be like the kth term test. And state what it tells you. So we're just going to do limit as k goes to infinity of this thing. So what is that limit going to come up to? 2. What does that mean? Diverges. If they were all mixed up, you would have to say diverges by what? Nth term test. But I told you in the directions to do an nth term test, so I'm fine with you just stating the answer. Okay, you usually have to cite which one of these you're using, but I told you in the directions, right? Same thing for this one. Limit as k goes to infinity of this thing. The denominator is going to go to infinity because the denominator is exponential. So good, it's going to go to 0, but what does that mean? No conclusion. And again, usually you would have to then start over, like find something else to try. But I'm just telling you to do the nth term test. So like the directions just say, I'm kind of letting you off the hook there. Okay. All right. These ones are P series. I'm trying to, on the quiz, divide them all up for you and tell you which one it is. On the test, they'll be all jumbled. Okay. So this is kind of like slowly removing the training wheels. All right. What do you think about this one? Close. It is going to be a fraction. 1/5. This is really n to the 1, and so it would be 1 over 5. So 1/5. All right. So converges or diverges? Diverges because p is a 5th, which is smaller than 1. And again, on your test, you would need to mention that it's a p series. But here, I told you in the directions, so you don't have to say it again. And then what about this one? Converges because p equals 5, which is bigger than 1. I feel like on the front page, the only one that was even sort of weird was D. Like most of these are okay, right? Yeah. That's not too bad. All right, integral test. Let me just do one or the other of these, and then I'll fill it in and post it on Schoology. But let me do one or the other. Which one would you like me to do, A or B? Which one? A. Okay, so you would do limit as B goes to infinity, integral 1 to B, and then you're copying that over, but just put an X in it instead, and that's a negative 1/2 there. Kind of like the negative ran into the fraction bar. This would be a U substitution. However, I want to kind of talk you through it without having to write every step. And again, I'm not telling you to be lazy. I'm trying to get you to be efficient. If there's a -1/2 in there, what's your adjustment? A -2. So just slap a -2 in front of the thing and then do the antiderivative. Antiderivative for E is E, like it's itself. You can write it all out if you want to. I'm just trying to get you to make that leap because the exam's timed, and if you can just do a really fast adjustment like that, then it'll save you some time. And then you're going to do upper boundary minus lower boundary. So the upper boundary will just be -2. Let me fix the negative exponent. The negative exponent means that's going to go where? Yeah, denominator. So it would be e to the 1/2 b in the denominator. And then if you plug in 1, that'll be -2 over e to the 1/2, whatever that is. And then lastly, you evaluate the limit. So as b gets larger and larger and larger and larger, what is this first part going to go to? Good, because the denominator is getting bigger and bigger and bigger. So this first part goes to 0. And then you would cancel these negatives. And it really doesn't matter what that is. The point is it came out to a number. E is a number. So what's your whole grand conclusion to the entire thing? It converges. And again, if they're all mixed up, you would need to say converges by integral test. I feel like that should be obvious because you did an integral, but anyway, you're supposed to cite which one you use. So converges by integral test. Because if it comes out to a number, then it's going to work. How would it look if it was diverges? It would go to infinity, which as a heads up is what this one does, but I'll fill that one out and then post the answer. Okay. These are alternating series. I'm telling you that, but I hope you could notice that, right? There's a -1 in there. So we're going to do an alternating series test. So it would be limit as n goes to infinity of everything except the part with the -1. You're basically doing an nth term test, and then there's just a second step to it. So where does that limit go? That goes to 0. So that means we're good. We can go ahead and do the second step. You need to prove that the terms are getting smaller and smaller and smaller. So you plug in n plus 1 for n. So I rewrote the series, but instead of n, I plugged in an n plus 1 for that. And I have to show that that's smaller than the series. And again, it's kind of like I'm writing it out the way I want it to be true and then checking if it's true. And you can try to plug in 1, plug in 2, plug in 3, but is this going to be smaller than this? Yes, because the bigger the denominator, the smaller the fraction. So what's your whole grand conclusion to the whole everything? Converges. And again, if they're all mixed up, you would need to say converges by alternating series test. If you just say converges again, that's fine because I told you it was alternating. Go ahead.
You wouldn't put a +1 on every single time, like on the denominator. You put a +1.
Yeah, and that's just because there was a +1 in the problem. I'm just using this part of it. Yeah, so I didn't invent that +1. That was kind of.
Your next question better be
All right, so looking at B, you would do limit as n goes to infinity of like all of it without the negative part. So where does that go? It goes to, why is it 1? Coefficients. This is n and this is n, so you'd use the coefficient. So actually, we're going to stop there. And your conclusion would be what? And actually, I'm going to erase those 1s because what does that look like? When I stuck the 1s in there, it looks like ln, and I don't want you to think that that's an ln. So we're going to say diverges, but it wouldn't be an alternating series test. You would say diverges by nth term test. It's like you didn't get far enough to even do an alternating series test because it just didn't work. And then these are the ones that we did today. So you're forced by the directions, and that happens sometimes, to do a direct comparison. So what do we want to compare this to? 1 over n squared. You're comparing it to something that's a whole lot simpler. So what does that one do? Converges or diverges? It converges because why? P series? Perfect. So here's what we're trying to say. Since that one converges, we want to say this one converges too. We need to prove that this one is bigger. If the bigger one converges, then the smaller one converges. So I need to show that this is smaller than this. And again, I just write it out the way I hope it's going to work. I made it work. Okay, it will work. Promise. So is that true? Is this smaller than this for n bigger than 1? Yes, because the bigger the denominator, the smaller the fraction. So your big conclusion is converges by direct comparison. And again, if you just write converges, I'll take that because I told you direct comparison in the directions. But again, on your test, they're going to be all mixed up. So you have to cite which one you use. And then the last one's a limit comparison, which I like better because you don't have to worry about which one's bigger or smaller. You just do a limit and it will work. And then you can just do your conclusion. So what do we want to compare this one to? 1 over n. Are we getting used to writing a sigma? Written it like a gazillion times now. So what does this one do? Diverges, good. Diverges because P series, P equals 1, good. And so what our goal is to say, since that diverged, the original one diverged too. And this one's a limit comparison. So we're going to do a limit. And again, it's going to look gross on the first step. You kind of have to trust the process. You're going to put that one over that one. So it's going to be a fraction over another fraction. But then you're going to do the reciprocal and it won't look so bad. In fact, after we do enough of these, I usually get people that will skip this step and go straight to flipping it over. If you feel comfortable doing that, you can skip writing this. I actually struggle with that, so I write it out every single time. Just mentally, I can't twist it. I have to write it and see it. Like I'm a very visual learner, so I always write it. But if you can skip this step and jump straight here, I'm good with that. So basically, we're not looking at these ones. Where does that limit go? 1. And the point is that not what you said? I thought you said 1.
No, I said,
So you definitely said 0.
Well, the point is, this is what?
non-zero.
Positive.
It's positive and finite. And so your grand conclusion is, since this one diverges by limit comparison, which again, you would have to put that on your test. If you just say diverges, that's fine because I put it in the directions. Again, I'm dividing them all up for you now. Later, they'll be all jumbled together.